On November 18, 2026, a piece of 1970s machinery will cross a line that nothing built by human hands has ever crossed. Voyager 1 will be nearly 26 billion kilometers from Earth. At that moment, a radio command leaving our planet will need a full 24 hours just to reach it, one light day. It has taken 49 years of continuous flight through the dark to get there, 49 years of falling outward, past Jupiter, past Saturn, and out into the space between stars. A signal covers that same distance in a single rotation of the Earth. Take that number and multiply it by 365. This is a light year. A span that took us half a century to reach, expanded into a single unit. The nearest star system to our own is 4.5 of those units away. Think of the light year as a physical wall. Every direction you push against it, the universe pushes back in a different, violent way. To understand that resistance, look at the Parker Solar Probe. It is the fastest object we have ever built, traveling at 430,000 miles per hour, fast enough to cross from Philadelphia to Washington in about a second. This velocity is a temporary orbit achieved by falling into the gravity well of a star. It is a stone whipped around on a string, and it only represents 64 thousandths of 1% of the speed of light. Voyager 1, which is actually leaving the system, travels at a much slower 11 miles per second. At Voyager speed, 1 light year takes roughly 17,600 years. When a ship traveling that fast would have needed to launch to arrive today, the last ice age was at its maximum. Every human being alive was a hunter. There was no writing, no agriculture, and no wheel. Chemical rockets convert a vanishingly small fraction of stored energy into motion. We have hit a hard limit in physics, making our current engineering irrelevant to the crossing. Suppose we solve the speed problem. If a vehicle reached 20% of light speed, the nearest star would be about 20 years away instead of 80,000. But the space between stars is not empty. It contains roughly 1 atom of hydrogen per cubic centimeter, scattered with microscopic grains of carbon and silicate dust. At walking pace, these specks are nothing. At 20% of light speed, they arrive with the kinetic energy of bullets. Hydrogen and helium nuclei stream in at relativistic energy, burying themselves below the surface of the metal. They form bubbles that blister and then tear the surface away in flakes, a process of continuous erosion that lasts for decades. To survive, the leading edge must be a shield designed to be destroyed. Some proposals suggest a massive block of ice that sandblasts away, losing a measured amount of itself for every year of flight. The object that arrives is not the object that left. It is thinner, pitted, and stripped. The quarantine demands a tax of matter for every light year crossed. Beyond the engineering, we face the weight calculation. In 2006, researcher Andrew Kennedy formalized a problem called the incentive trap. This chart shows a slow trajectory launched at year 0, intersected halfway by a faster ship launched a century later. Because technology improves, a crew departing today is overtaken by descendants, finding the destination settled by strangers who left long after them. This logic creates a recursive delay. If you know you will be overtaken, you stay home. This mathematical valley shows a specific moment centuries in the future when the sum of waiting and traveling is smaller than at any other time. According to the equations, the only rational decision we can make right now is to wait. The choice to leave belongs to people separated from us by more time than separates us from the Norman conquest. We expect Einsteinian relativity to be the villain, but at 20% of light speed, time dilation is a rounding error. The crew ages about 2% slower than those at home, a difference of months over a 20-year crossing. The true divider is duration. A crew 1 light year out sends a message that takes a year to arrive. A reply takes a year to return. 2 years for a single exchange. There is no conversation, only a broadcast into a delay. A crew must expect that the institution which launched them no longer exists in any form that would recognize their call sign. You could travel for 1,000 years, and the constellations would not visibly change. You would move at incomprehensible speeds for longer than recorded history, and the view from the window would be identical on the last day and the first. This separation from history is caused by simple duration. The journey takes longer than civilizations last, leaving the travelers severed from the concepts of home and progress. The metal erodes, the clocks stay honest, the messages take years and then stop. The sky remains frozen, and the sun becomes just another star in a sky of them. The human strategy of exploration, going, looking, and returning, is broken by this scale. Humanity is an island species. Even the closest stretch of the cosmic ocean remains hostile to our ships. Voyager 1 will pass a dim red star in the year 40,272. It will be a dead machine, carrying a golden record inscribed with a language that has become unreadable, long after the agency that built it has become a footnote. Interstellar travel is not a story of triumphant arrival. It is simply the story of inertia, carrying dead artifacts outward into a silence that has no far side.